Yeah. Yes, yes, yes. Fellow ng-conf attendees and ng-conf extended viewers, what is up? It is so cool to be back up on this stage again this year. All right, time to get after it. I'm Justin Schwartzenberger, and you know, I think I'm finally at peace with components. See, a while back I went on this journey to seek component enlightenment, to understand the ways of componentization. Now, my journey to finding component tranquility began a few years ago. It was late 2014, and Tobias and Igor were up on a stage wearing these Angular shirts with these big numbers on them. Tobias in his 1.3 and Igor in his 2.0. And as the world watched on in anticipation, they stood up there telling us about this new iteration of Angular JS, talking about the coming changes. And it was in that moment when Igor told us, in Angular 2, we are embracing the component model. So from the beginning, it was about components. And as this Angular alpha and beta and RC unfolded, the component story began to be revealed to us. Where Angular JS was about taking logic and applying it to chunks in the DOM, Angular was about isolating those chunks, along with their logic and markup and style, into components, and then building out a UI from a tree of those components. And this wasn't about Angular becoming something revolutionary. This was about Angular becoming a solution and learning from concepts and implementations that were currently in circulation and being explored. Concepts like web components and implementations like Polymer, and frameworks like React that had this concept of components at its core. Following in the footsteps of these other solutions that took this component architecture approach to building applications. And this certainly felt like a sensible approach. But us as implementers, when we started to dive into this thing, we realized that the web dev game was changing. With Angular, we need to become component architects. All of us, our thinking and approach to building these UI views has had to change. When we take a mock-up like this, something that displays a list of player cards with some summary text like name and score and a call to action button, we used to plan our implementation like so. We'd see this container that we need to loop out items in, and we see some repeat styling and structure and an interactive UI piece, and we would think in terms of one markup chunk that we'd apply a bunch of scripting logic to do the loop out and to wire up click events, right? Well, with this new architecture approach, we come out of the gate thinking, cool, no problem, we got this. Now we just need to start building these things into components. So we see a component for that player card, and we see a component for the list of cards. Oh, and we could totally make a component out of that call to action button, and that would be sweet because then we'd have this reusable piece in our application, right? And from here, we fall in love with and start crushing hard over the component model. We learn we can scope our styling to components, we can send data down into our components via inputs and broker action back up out of our components via outputs. We're like, hot dang, this is amazing. And we want to componentize not just some of the things. You know we want to componentize all the things. And then we panic. Well, I panicked. I don't know, maybe some of you did too. See, my shorty sense started tingling, telling me, dude, this can't be good. Componentizing at will? I mean, look, there was a time, like in the 90s, late 90s, when doing web design and layout with nothing but table tags felt pretty amazing too. And the next thing I knew, I was loading up my DOM with heaps of TDs and TRs and call spans everywhere, and Netscape Navigator came grinding to a halt, and I began to question my career choices and whether I should ever open up Macromedia Dreamweaver again. Those were dark times for me, and I don't want to revisit them. So I thought, there has to be this price that we pay when we build with components. But what do we need to know to really understand this cost, this component tax? Well, to begin with, we need to understand what we're getting with components. Sure, the fact that a component has a template and some logic and some styles, pretty straightforward and understandable. But what are we really getting? Well, with the Angular platform, we're getting an engine that will take those three pieces and render them. We're getting an engine that will watch over a component tree and dependencies and change detection and handle orchestrating all of that together. And we're getting a compiler that will take these component pieces and build them into something efficient for that engine to use. Now, Angular needs to do these things for each component that we have in our application. So if we have one component that handles all of our markup and logic, Angular just needs to do these things for one. But if we start making components out of that markup and logic, we're increasing this workload. And when we talk about the compilation of components, we need to understand that for each component that we add to our application, we're adding to our JavaScript payload. Not only the HTML, CSS, and scripting, which all get compiled down into JavaScript, but also all of the bits that Angular needs to do its component thing. And this is really the first component tax that we can identify, the payload tax. And as Angular goes to do its component thing via the bootstrap of our application or the lazy loading of our routes, it needs to do prep work for all of these components that we've declared within our ng module and any referenced ng modules. And as Angular does its rendering, it's making display decisions and doing change detection on those components. And these make up the second component tax that we can identify, the execution tax. And look, for these two line items, that's just how it is. It's part of the cost of admission. But that's okay, because we can do amazing things with this platform. And as we've seen with the recent 4.0 release, and as a pattern from day one really, is that the Angular team keeps refining this platform to make it better and faster at doing these things. But it's different than just taking a bunch of markup and applying some scripting logic to it. Deciding to make a component for an item in a list instead of just putting that markup within an ng4 has a cost to it. And we need to understand these cost details in order to become component architects. But when we do, we start to gain clarity. And this is when our watch really begins. See, there's these patterns that start to arise as we go deeper and deeper into building out applications and features in this component world. For example, we tend to take a custom element selector first approach when building our components. We come up with an element name for our selectors, and then we use that within other component templates. And then we build out the markup that we want to render within that the component. And then we quickly fill up our DOM with these custom elements everywhere that act as containers for the content that we really care about, which is the guts of the template. So the next component tax that we can identify is the container element tax. That custom element that we're creating where our template content goes. And we start to feel this tax when we build out components that use a container element as the top level node of their template content. For example, we have this component here that's going to render a section element. Now it starts to feel weird that we're rendering that section element within a custom element. That custom element is not really needed for anything. And the part that we really care about is the inner contents of that section element. And we start to feel this when it comes to styling, because custom elements are not block level elements by default. And if we need them to be, we end up using something like :host to put it on. And then we repeat this same pattern in all these other components in our application. And because this markup and the CSS is part of the component, it's getting built down into our JavaScript payload. And now we're paying this extra tax. Because now we got this markup and the styling, which is not ideal and really not what we're trying to accomplish here, yet we're increasing our payload. No worries, we can deal with this container element tax. See, in addition to element names, we've got class names, attribute name and value, and even not selector logic at our disposal for component selectors. So we can start thinking in terms of targeting existing elements instead of a custom element. So we could do things like target a native DOM element, like our section element here, by making use of an attribute selector in our component. Then we don't need that section element within our template. And we can get a win out of the native block level elements, so we don't need that added CSS. So as component architects, if we commit these component selector options to memory, we're going to be better prepared to make sound decisions during the planning phases that will help us reduce this container element tax cost and mitigate some of the costs that we pay for that payload tax. And we know the selector stuff because we use it for directives. And a component is a subset of a directive. So it makes perfect sense, right? But most of our training around components has been focused on custom element selectors, which leads to examples being written that way, which ultimately leads to us taking a custom element selector first approach when we build our applications and libraries. See, when we just consume and repeat and never journey in and discover, we end up building somebody else's something. But when we understand what's going on under the hood, we empower ourselves to architect our something. Okay, So the payload, execution, and container element taxes, those we can identify on an individual component basis. But what about when we start to craft compositions of components? Let's have a little discussion about the decision and presentation pattern. The decision and presentation pattern is one in which we create these parent components that are only responsible for loading and altering data. And then we create these child components that are only concerned with presenting data handed to them or requesting interaction back up out of them via the use of inputs and outputs. And right off the bat, we can see a benefit to this type of architecture in our Angular applications. These presentation components become simpler. They become easier to reuse. We can set change detection on them on push and get better performance, right? All valuable things, all worthwhile things. But there's a tax in there that we start to pay as we build out with this architecture. The tree coupling tax. And we start to feel this tax as we build out our displays for these decision components because we start to couple our presentation components to it. So let's take our scenario from earlier with the player cards, right? We've got this decision component that's going to handle loading the list of cards. And we've got this presentation component that's going to handle displaying the card data. And this works out pretty well because in this decision component, we can have a property for the cards, and we can have a method in there to upvote a card. And then in the template, we can ng-for over the list of cards, pass the card down to the presentation component via the input, and then use the output to wire up to our upvote action. But what happens when the day comes, and it will, that we go into our card component and we decide, you know, we could really benefit from making a component out of that upvote button. Well, our new upvote button component, it's going to need an output on it to broker up that action, right? But now we've added another component to our component tree. And our list component is still the one responsible for making the decision to upvote a card. So now we've got to wire up our card component to our new upvote component's output. And we still need to wire up the list component to the card component's output. And all of that output there in the middle in that card component is only there for pass-through purposes. And the more that we tree this thing out, the more of that chaining we end up needing to do. So now we think about not making so many components so we don't have to pay that tree coupling tax. But that's not really where we want to be because there's good reasons to make these child pieces into components. Look, everything's got a tax. As developers, we're constantly battling to put queen-size sheets on a king-size bed. And that's okay. It's a give and take. It's really about understanding our costs and making smart decisions on where we spend our architecture credits. So what are our options here? Well, we can make use of services. We probably already have a card service that this list component is using to get the list of cards. So we could add a method to that service to upvote a card. And then in our upvote component, we could inject that service so that it could take action on that card, and we wouldn't need that output chaining. But now we need to have a way to get the card ID into this upvote component so it knows which one to take action on, right? So we'd probably use maybe an input chain for that, which I guess is better than an output chain because it doesn't have event emitters. I don't know. Let's say we're okay with that trade-off, right? Well, how do we get the card component to update its view when it's upstream, and this one's the one making the decision to change the data? Well, we could update our service and return the cards as an observable, then that way things could subscribe to it and get push updates. But now we need to send this card service into any other component that needs to work with that card data so that it can subscribe and get updates. And we quickly continue on from this and start building out other services to represent other entities in our application. And if a component needs to work with 3 different entity types, we end up injecting in 3 different services. And if another component somewhere else needs to take action on a different entity type, it either needs that entity service injected into it or needs some other way to broker that action. So this component tree and the need for the nodes within it to work in harmony yet not be coupled becomes a real architecture challenge for us. And as this starts to play out, we see where something like a redux pattern to manage application state could be useful. With a redux pattern, we have this concept of a store that keeps application state and exposes it via an observable, and then provides a way to dispatch actions to change that state. And this works out pretty well because now we can start thinking about making our components in our application deal just with the store. So that may reduce some of that server injection complexity, and it allows us to start moving these components around both vertically and horizontally, and even adding new components into the componentry mix without having to worry about that coupling and that chaining as much. So all of these approaches help, but none of them truly eliminate the tree coupling tax. What we begin to realize is that it's a combination of these in which our answers lie. Our understanding of them and ability to orchestrate them is where we're going to find harmony. So, let's say we're tasked with building out a tool that helps HQ track a team of operatives as they infiltrate a flashpoint that's under duress. And this tool is going to have a list of active team members on one side and a big giant map that shows the current location of each. Let's put our component architect hats on and go to work on this thing. So we see this tool as a whole, and we could identify that as a page view, right? Now this page view is going to be made up of a list and a map, and those are going to be a composition of components, because they're going to have child pieces that are unique to each of them. But if we look closely, we can see this common element that both of them use, and that's this team member avatar coin. We can identify that as a global component, something we want available to the list and the map and the application as a whole. And as we break this thing down, what we're doing here is this atomic design methodology, a pattern that Brad Frost established to help tackle designing systems of components for the web. And we can start using these solutions that we have at our disposal to tackle some of these design challenges. So at the page view level, let's say we want to leverage some native DOM elements like the aside and article. Well, we could create those components using attribute selectors. And that list and that map, they're going to need to keep track of all the team members, so they can get a team member service that makes use of an observable so that their data can stay in sync. And that list and that map are going to be a composition of components, so we could build those things out with the decision presentation pattern, since we can see from our mock-up that they're not too complex, so they're probably not going to get that much tree depth, right? And that team member avatar coin, we know we want that thing available to the app as a whole, so we need to build that thing completely decoupled. So we could use only inputs and outputs on that global component, throw that thing into a shared ng module, and then make it available to other ng modules in our application. So we're able to make these architecture decisions because we have an understanding of how Angular does its component thing and of the give and take to the potential approaches of the many scenarios that will arise. And we have a clear picture of the cost to componentize and can now calculate ways to bring balance to our architecture budget. And with this newfound clarity, we're able to make decisions with intent. Our decisions, adapted for our scenarios. And we can take a deep breath and relax and embrace this tranquil component landscape that lies before us as we step into our roles of component architects. Thank you. May you all find component tranquility.